Chapter 6: Electrical Diagnostics and Wiring Best Practices. Electrical issues are one of the leading causes of valve failure and sprinkler system malfunctions. Proper electrical diagnostics allow technicians to quickly identify whether a problem originates at the controller, within the field wiring, or at the valve itself. Accurate testing saves time, prevents unnecessary repairs, and significantly reduces callbacks. Testing voltage throughout the system should always follow a logical, step-by-step path. Begin at the controller and verify output voltage at the terminal. From there, test voltage at wire connections, splice points, and finally at the valve solenoid. Any voltage drop between points typically indicates a wiring issue, poor splice, or damaged wire that must be addressed. Understanding ohm readings is critical when diagnosing valve solenoids. Ohms measure electrical resistance and help determine whether a solenoid coil is functioning properly, damaged, or shorted. Ohm testing should always be performed with power disconnected to avoid inaccurate readings or damage to your meter. Acceptable ohm ranges can vary by manufacturer, but most standard irrigation solenoids should read between 20 and 60 ohms. A reading significantly higher than this range often indicates a weak or failing solenoid. A reading near zero usually indicates a shorted solenoid. Any reading outside the acceptable range should be treated as a failed component and replaced. Proper wire splicing is essential for long-term system reliability. Clean wire cuts, tight connections, and correct wire matching are standard for professional repairs. Sealing connections is especially critical in two-wire systems. Poorly sealed or unsealed connections allow moisture intrusion, which leads to corrosion, signal loss, and intermittent valve operation. Always use approved waterproof connectors and ensure every splice is fully sealed before closing the valve box. Electrical troubleshooting is not guesswork. It is a structured, repeatable process. When voltage testing, ohm readings, proper wiring practices, and sealed connections are done correctly, technicians can confidently diagnose valve problems and deliver long-lasting professional repairs. Before moving on, remember this: understanding voltage, ohm readings, and wiring best practices gives you the knowledge, but applying those skills correctly in the field is what truly matters. In the next video, you'll see a step-by-step demonstration showing exactly how to use a voltmeter to troubleshoot valve issues. We'll cover proper meter setup, where to place your leads, how to interpret readings, and how to use those results to confidently diagnose valve and wiring problems in real-world situations. Watch closely. Mastering this skill will make you faster, more accurate, and more confident on every service call.